Hi guys! In this video I'm going to explain the concept of variables that are local to threads, which are also called thread-specific data. So what does that mean? Suppose I want to create 5 threads, as I've been doing so far, but I want a variable to be only local to that thread. Meaning, I want to replicate counter as a local variable for each thread. So instead of counter being a global variable, as I usually do, I'm going to add 2 underscores thread, and this is going to create a local copy of the variable counter in each of the threads. So let's have a look at how this would be. So first of all, I have the main thread that has the counter 0, and then I'm going to create additional 5 threads, alright? And each of these 5 threads that I'm going to create will have a copy of this counter, and it's also called counter, and will be initialized to 0 as I've done. Alright? I know I haven't created the threads yet, but this is the way it's gonna be. So let's go through the code step by step. First, I'm gonna create an array that's called threads, which will store the thread IDs, and this will be passed with pthread_create. At index t, the thread will have its ID stored there, and I'm instructing it to take the default thread attributes and execute the print hello subroutine, which does not have any arguments. Okay, so what does this do? Oh, and of course I'm creating this t here and error. So I have a threads array. So when the first thread is created, I'm gonna have an ID here 1176 2357. I don't know what, and I have 2 local variables in the main thread, which are t and er. Okay, and I'm also gonna have another array which I'm gonna call thread indexes. And this is it basically. It's gonna store the index t. So it's gonna store the index of each array. Alright. After I created those threads, I have to print the value of the counter. So by that time, if each thread is waiting 1000 milliseconds, the main would probably execute before any of the threads, so the counter will be 0. But let me put this statement here, where I'm super sure, I'm 100% sure that the main thread has waited for all the other threads to finish, right? Because I have a pthread_join statement over here, and the pthread_join statement is gonna block all of these threads until they've completed their work, and then the main thread will be allowed to continue its execution. Okay, so this is the code. What do you expect the value to be? Let's run it. Okay. And the value of the counter is 0. This is my latest execution, by the way, of the code, so here it is. The value of the counter is 0. Why? Why is it 0? Because after each of these threads has finished execution, their stacks will be deallocated. So basically what's going to happen is this stack will be deallocated, this will be deallocated, all of them will be. And anything that was stored in those stacks will no longer be accessible. And when I say printf the value of counter, the only counter value that I still have, and I can access by the way, is the one that's in the main thread, because the main thread is still alive, it hasn't died yet, and it has a value of 0, because if you notice, only the other threads that were created have incremented the value of the counter, but the main thread did not do anything to that value, and therefore it's still 0 as initialized. And it is thus expected that the value that will be printed is 0. But what if I actually want to check the work of each thread. I want to see the value of the counter, or the value that was incremented by each thread. What can I possibly do? Well, one solution is to actually have the counter as a global variable accessed by all threads. So here I'm going to store an array called counter, which basically has 5 spaces. Okay, so it's equal to the number of threads basically in size, and whenever each thread is supposed to execute, print hello, whereby it increments the counter. I'm not gonna let it increment a local value, but instead I'm gonna let it, okay, so I'm gonna initialize these to zeros, and whenever each thread executes, I'm gonna allow it to increment only the area that corresponds to that thread. So for example, T2 will be allowed to, if T is 2, so the third thread executing with index 2, I'm gonna allow it to modify this in the global variable, so it's gonna become 10, and so on and so forth. And when all threads finish execution, I can loop over this array and add the results. So that's one way. And why does this way work? Because I'm not writing to the same memory location. I'm writing at different memory locations here. However, if I have the global variable counter as only an int, and those threads are executing at the same time, they could be writing to the same memory location at the same time, and because they're doing that at the same time, one might overwrite the effect of what the other thread is executing. So, like if the counter was 20 and then 2 threads came together, maybe the result will be 30 instead of 40, because only the last one, the effect of the last one what was like viewed in the counter. And therefore, having a global variable as an int does not work without having proper synchronization methods that we'll learn about. But now, since we don't have those proper synchronization methods yet, let's do this way. Let's implement it this way. So the first thing I did was change this into a global variable, but as an array. Okay, so this is what I did. And here I'm gonna create a local variable called index, because I want to know the thread's index, and it's gonna be I'm gonna have to cast that value of the index that I've received as an argument. So let's do that. And here the counter is no longer an int, it's now an array. So at the index I'm gonna add 10. Alright. But notice here I forgot to actually dereference it to get the value of the index. This only gives me the pointer, but I want the dereferenced value of the pointer, so I use the dereference operator. And what else? Well, here I need to pass the index, so I'm gonna pass and T indexes number of threads. Okay, but here let me put the index. Yeah, so at every iteration I'm putting the index in thread indexes. And I'm passing that location by reference, so I could get the value here. Okay. Now, to know the total counter, I'm gonna define here a variable called total counter, initialized to 0, and I'm gonna loop, I'm gonna loop t less than num threads and t plus plus. So every time total counter will be incremented by the value at counter position t. Yep, that's supposed to work. Let's test it. Okay, I have to compile again because I've done a lot of changes to the code. Num threads undeclare num threads. Okay, let's see what this is about. I'm not sure if I've used this before, declaring num threads. Let me try doing this. I'm not sure. Okay, here I have to change this to final counter. Sorry, total counter. To match this, let me see what errors we still have in the code. Okay, the other error is that I called this index, which is exactly like this, and I can't do that, so I changed it to end, and I think this made it work, so let's try this again. Yep, it did. Okay, I'm compiling, see, no errors. Now let's see the moment of truth. The value of the counter is 50. And this is what I was expecting. So I got the value from each thread, and yep, that's what I did. And I added like okay, let me explain it here. So yeah, every thread basically edited those values to 10, and what I did in the final, was it called final or total? Total, okay. So what I did in the total counter is that I just looped over that and added those numbers and got a 50. Which is exactly what I expect because I have 5 threads. And this is it for this video. I'll see you in the next one. Bye!